Hi, this is Nick Rendeleone. Today we're going to talk about the basics of trigonometry, and for that we need to understand that trigonometry is all about triangles. Right? That's where the name comes from, trig as in triangles. A few basics. We're going to measure the angles in something called degrees, and there are 360 degrees in a circle. And it's going to be key that we understand what a degree is. It's going to be important as we measure. In more advanced mathematics, we use something called radians, which we won't talk about today, but it's also good to know that there are more than one way to measure an angle. Also, the most important thing about right triangles is that they have the following three sides. The sides are labeled opposite, adjacent, and hypotenuse. Now the hypotenuse is a funny word, but it's the easiest to remember. It's the longest side in a right triangle. So it's usually the diagonal in any triangle that we're talking about. That is typically the longest side. Now let's look at the picture on the left. If you notice that we're actually going to be measuring from angle B. That's sort of the highlighted one, a little dark angle. And from the perspective of angle B, the side that's closest is always the adjacent. The side that is what's called the opposite side is the farthest from the angle we're measuring, and as mentioned, the hypotenuse is the longest one. Now look at the diagram on the right. We're measuring from angle A. Now angle A, the closest side is this side, and we call that one the adjacent, and then the other one is the opposite, and the longest one again is always the hypotenuse. So it's important to know that these sides are all relative to the angle that we're measuring. And of course, as we're talking about right triangles, there's always going to be a right angle in the middle of that triangle. All right? Basics. The reason that we use these right triangles for trigonometry is that we can leverage or use the Pythagorean theorem. Even if we don't use it directly, it's hiding in the background. And the Pythagorean theorem is really the most, or one of the most important theorems in all of mathematics. It's just so important. Let me put like 3 stars next to it. Just the most important. And we use it all the time in elementary math and the most advanced math. The point about the Pythagorean theorem is that if you know 2 sides of a right triangle, you can always find the third. So if we happen to have a triangle and we know any 2 sides, it doesn't matter what, we can figure out the third. Now, we're not going to talk about the Pythagorean theorem that much because we know that we've done this in other classes, but the point being is, for example, this is a 3, 4, 5 triangle, which means that 3 squared plus 4 squared equals 5 squared. Oops, let me go here. 3 squared plus 4 squared equals 5 squared. And that's 9 plus 16 equals 25. 9 plus 16 equals 25. So that's the basics of the Pythagorean theorem. But today we're trig functions, which ultimately are based off the Pythagorean theorem, but we have to remember some other things. And the things that we really have to remember is that there are 3 primary trig functions. They're called sine, cosine, and tangent. And they're spelled a little bit different than the way we pronounce them. This is spelled sin, cos, and tan, but that is just short for sine, cosine, and tangent. And these 3 trig functions are defined on those words we just learned: opposite, adjacent, and hypotenuse. And the sine, we'll do that first, is the opposite over the hypotenuse. So let me show you what that one is. If we're using this angle here as our angle of reference, this is going to be our opposite, and this will be our hypotenuse. So it is going to be BC over AB. Cosine is going to be the adjacent, or AC, over hypotenuse, which is AB. And then finally, tangent is opposite over adjacent. Now, sometimes we talk about it in these terms, and sometimes we also use what's called a unit circle. A unit circle is this triangle here with a hypotenuse of 1, and it's usually drawn inside the circle. And the reason why we can do that is, well, let's look at what the cosine would be. The cosine would be this side, which is the adjacent side, over the hypotenuse. But if the hypotenuse is 1, that means that this length is the cosine. And likewise for the sine, it is simply this length is the sine. And then the tangent's a little bit funny here. It's this one over here. We can extend this triangle out here and make it a right triangle from here, here, and here, and the tangent is this length. So the sine, the cosine, and the tangent can be also defined that way. All right? It's very important to remember these definitions because you're going to use them. It's really hard to remember sometimes in the beginning which one's the sine, which one's the cosine, and which one's the tangent. In English, we have this very, very funny expression that we sometimes use, and it's SOHCAHTOA. SOHCAHTOA. And the reason we do that is because so, which I can do that, here I'll show you the so part, that stands for the sine, and then the O is the opposite, and the E is, well, that's how that's how you say it, so, but it's actually, let me move this over here. Where's my little hand? I'm going to move this over here. So is S-O-H, even though it's spelled, or you sound it out so. That's sine over opposite and hypotenuse. And again, opposite divided by the hypotenuse. Now, the ka is for cosine. Cosine is the adjacent over hypotenuse. And finally, the tangent is the opposite over adjacent. So SOHCAHTOA. If you can remember that and sort of unravel the way we write it, then you can remember the expression SOHCAHTOA. Okay. What is the point of all of this? Why do we learn these expressions? Well, very, very useful in physics, very, very useful in navigation, very useful in finding different lengths of objects. So one of the very first examples, and one of the most famous, is that a wise Egyptian, a wise Greek who was traveling to Egypt was called one of the 7 wise men of Greece, and his name was Thales. And about 600 BC, he was able to figure out, using similar triangles, the height of the pyramids. And the Egyptians thought he was brilliant for that. So figuring out the heights of things. So what is it all used for? Well, as mentioned, Thales in 600 BC was able to measure the heights of the pyramids, used in navigation, used in physics, used in all sorts of elementary calculations to figure the height or the distance of objects. So very, very, very useful in engineering and in basic sciences. So let's do a problem to show how we can do it. Okay, so here we go. We have a tree that's been measured from the height to the base is about 25 degrees. So 25 degrees is going to be our angle of reference. Now, what do we have to work with? Well, we know that the base is 20 meters, and we want to find the height. So we would model this using a trigonomic function, and as we are looking for the height, and the height is actually the opposite, oops, let's go this, the opposite, and we happen to have the adjacent side, we know that that is a tangent. All right, so let's model this using the tangent function. And the way we do that is, let me clean this screen up so we can get going. And that means tan of 25 degrees is the same thing as the opposite, or the unknown, which we'll call x, all over 20, which is our adjacent. Now, how do we get the x by itself? That should be pretty easy. We're going to multiply both sides by 20, and that will give us 20 times tan 25 equals x. And tan of 25, best thing to do is to either look it up in a table or simply punch it into your calculator. And it is about 20 times 0.466. And if you multiply that out on a calculator, you will get that the height is about 9.3 meters. And that is how you can use this to find the height of a tree, a rocket, a flagpole, what have you, using tangent. If you have other measurements that are given to you, you can use the sine or the cosine. But we'll do that in another video. Thanks for listening. Bye.